Hey, Algebra students, let's take a look at these advanced level equations from the solving a two-step equation lesson. And you might say, well, what makes them advanced, Kate? Well, what makes them advanced is they're not actually two-step. It's not that I can't count. It's that we're going to just use these same skills and up our game a little bit for some three-step equations. Let's take a look. Okay, I'm going to pull out another color, which I like to do for students so they can see what's going on more clearly. I love to put a little line through the equal sign so I'm really clear about what's on the left-hand side and what's on the right-hand side, right? My goal here, remember when I'm solving, is to get that letter by itself, Q in this case, so that I can know what Q is equal to. If it's by itself on one side of the equal sign, then that tells me what Q is, what Q equals. And then so that's my goal. And why is this a three-step? Well, there's three numbers to get rid of. I've got a 3. I've got this 2, and I've got this 5. Okay. Now, do you remember when we're getting rid of math, we're throwing it across the equal sign is one way to think of it. But when we are doing that, we are actually going to move in our opposite orders using inverses and opposites, and even the order of operations is going to work opposite the way it usually works. So in theory, I'm going to move anything adding or subtracting first, but I got to show you a mistake that students make. This is the reason why I picked this thing to do. They go, well, look, 2 is subtracting from Q. I'll move that first. I'm a good obedient student. That's what Kate told me to do. And I said, no, that's not what I told you to do. Take a look at this entire process of order of operations. Remember what each thing stands for. G is for groupings. E is for exponents and their inverses, so roots and radicals, basically. M is for multiplication and its inverse, division. And A is for addition and its inverse, subtraction. So yeah, you move addition and subtraction first, but scoot all the way to what you do last. You're going to leave groupings for last. Let's say that again. Leave your groupings for last. And don't forget that one of the ways that we group is with the fraction. The numerator and the denominator of a fraction form natural groupings. They form natural groupings. So what in the world does that even mean to us in this case? Well, take a look. We have a grouping on the top of this fraction. We have math to do up top. That 3Q minus 2 is a group. Is a group. So what does that mean? That means leave it for now, right? Leave it till last. Get rid of anything that's outside of the group first. That 5 is outside of that grouping, and so that is what I'm going to send packing. That being said, though, how do I get rid of it? Well, remember what it means when you see a fraction bar. That means this entire group is being divided by 5. If you want to free the entire group from being divided by 5, then you need to multiply the entire group by 5. And be nice to yourself. Make that 5 line up nice and even with the top of your fraction so it's clear that it's multiplying. If you do it too low, you might accidentally divide or not know what it's doing. If you do it too high, like you put it up in the sky, you might mistake it for an exponent. Now, we can do whatever we want as long as we do it to the other side. So I'm going to take the entire left-hand side. Multiply that by 5 as well. And let's see what we get. Well, on the left-hand side, that's easy. 5 times 4 we said we'd do. Let's do that. That gives us 20. And interesting thing on the right-hand side, dividing by 5 and multiplying by 5, they're opposites. I just got rid of that ugly fraction that I hated. And what's left? Just the 3Q minus 2. That's what's going to be equal to the left-hand side. Don't drop your equal sign, guys. But notice, now I've freed my group up. This 3Q minus 2 is no longer in a grouping. And so now I will be able to get rid of that minus 2. So I'll add 2. I can do whatever I want as long as I do it to both sides. Make sure you get all the way across that equal sign. That's what I mean when I say both sides. I'm talking about both the expressions, the expression on the left and the expression on the right. Okay, what is 20 plus 2? Well, that's just 22. And then what is that going to be equal to? Well, if I subtract 2 and I add 2, that zeroes out. There's nothing left to add or subtract with 3q, so it's just 3q. And now what? Well, q's still not alone. I got this 3 to get rid of. What's it doing now? Well, they're shoved together. It's multiplying, so I'll divide by 3. I can do whatever I want as long as I do it to both sides. Almost done now, guys. Multiplying by 3, dividing by 3 cancels. Yay, q's alone like I wanted. But here's another place where students get stuck. Another reason I wanted to do this problem with you. You guys go in your calculator. You say, hey, 22 divided by 3. It gives me this number, 7.33333333. And you go, I'll just round it. I didn't tell you to round it. I have no hint that I want you to round it. This is not a real world situation where rounding it needs to happen in order for the number to make sense to us. Guys, mathematicians generally prefer a fraction over a rounded decimal when we are in the area of pure math. This is like pure math, okay? I'm not rounding. I'm not estimating. Okay, so that being said, final fraction answers, though, should be reduced. So if you're not great at reducing fractions, you can type it into your calculator using the using the fraction bar instead of the divide by symbol. So type n over d and then type 22 over 3 just to see if this sucker is reduced. But I happen to know this sucker is reduced. It's not going to go any simpler than that. And so 22 over 3 is my final answer. It is the preferred one for most mathematicians. Stop panicking at the sight of fractions, and especially improper fractions with these large numerators, and just chill. That's a legit answer. I like it just fine. My work here is done. Woo! Okay. Woo. Guys, you're doing great. Let's move on to this next example. All right, 2/3 times the quantity of 12x minus 9 equals 18. Now, there's actually a second way to do this problem that you'll learn later in the crash course, which is totally legit, where you pass out the 2/3. You basically do the multiplication with the grouping. But we haven't done that yet. We haven't learned that yet. All we've done in this lesson so far is get rid of these numbers so that the letter can be alone. And that works too, right? We always have that choice in algebra. We can either do the math we see, that's simplifying, or we can get rid of it. We can move it over to that other side of the equal sign, solving. And so that's what I'll do, since that's the skill we're practicing right now. Your way's legit too, though, if you do it the other way. But what I notice here is that this is a grouping. Let's save it for last. But this 2/3, it's multiplying with the grouping. So I'm just going to do the opposite of multiplying. I'm going to divide this whole group by 2/3. And once again, there is another way to do this. If you know it, good for you. But I'm just sticking with the one skill we've been practicing this lesson. Okie dokie. So let's take a look at what happens right there if I work to cancel out or to remove that grouping. We want black. Okay. Remove that grouping, dear Lord. Remove that multiplier of 2/3. Okay, the thing outside the grouping. So multiplying by 2/3 and dividing by 2/3 are opposite. They cancel. And so you freed up this 12x minus 9. Now, a lot of students are like, do I need the parentheses or do I not? Now, that was a grouping, but there's nothing else going on now. So there's no reason to have these parentheses because I've got nothing else. I've freed my grouping. So it's just 12x minus 9, and that's going to be equal to whatever I get on the other side. And I would totally do this in my calculator. If you know how to divide with fractions, that's super awesome, but we've got a lot of things to do. So this is how I would type it in my calculator. I'd do 18, the divided by symbol so you don't get confused with the double fraction, and then over n over d, 2/3, and I get 27. Yep, it cleaned up that nicely. All right, and now this is a lot easier to solve. You guys are skilled advanced students. I'm not going to slowly walk through it, but now I can get rid of the thing that's adding or subtracting, and I will see that lovely cancellation, so that 12x is alone. Now that the 9 is free from the grouping, now I can move it, and 27 plus 9 is 36, almost done. That 12 is multiplying, we'll divide to get rid of it. And then my final equation where x is alone, so I know what he's equal to, is going to be, let's see, 36 divided by 12. X is equal to 3. Nice. Okay, let's do the last one. Real fast, you guys. Okay, x cubed minus 4 over 3 is equal to 20. Once again, we have a grouping on the top of that fraction, okay? So we'll take anything outside of the grouping first. The 3 is outside. It's dividing, so I'll do the opposite. I'll multiply. And you might say, Kate, isn't this like the first one? Why are we doing something similar? I promise I have a reason for doing this one too. Okay, multiplying and dividing by 3 cancel. That group is free like I wanted. 20 times 3 is 60. Now that add subtract is free from the grouping, I can get rid of it by doing the opposite. And new equation then would be just this x cubed equals 64. Now I have 2 general reactions from students to this equation. Here's why I wanted to deal with this one. X cubed equals 64. First wrong kind of reaction, but that's common, is students just stop here. X is alone. Yeah, no, X is not alone. This is not what X is equal to. This is what X cubed is equal to. I need to keep going, okay? But second reaction is basically panic. I don't know how to get rid of a cube, okay? Oh, maybe there's a third reaction. The third reaction that's also not good for me is they do the square root. So they kind of partially remember that the opposite of exponents is radicals, but careful, that little radical by itself, the way it stands, is a square root. Square root is the opposite of squaring. So that's what I would do to get rid of a square. I don't have a square here. You know, I have a cube. I've got to get rid of a cube. In order to do that, you don't want the square root. You want the cube root. That looks like that little check mark radical, yes, but with a little 3 tucked in the check. That's tricky. Let's do the exact same thing to the other side, guys. Don't take the cube root of one side and the square root of the other side. You just abuse the equal sign, and everything you get from then on would be nonsense. All right, so cube and cube root are opposites. They cancel just like we wanted. X is alone. Hey, and now we talked about perfect cubes at the advanced level back in Unit 0 when we did perfect squares and their roots. But if you don't know your perfect cubes, that's fine. You know, guys, you can do this in your calculator. But I happen to know my perfect cubes. I know what number cubed equals 64. That's 4. Because if I were to multiply 4 times 4 times 4, I would get 64. And so the cube root of 64 is 4. Now, if you don't know how to do that by hand, that's okay. You would have your calculator on the GED when you did this. So go check out the calculator example for exponents, roots, and radicals. I think it's just calculator for exponents. But for now, we will just focus on the skills that we are studying, how to solve these equations. All right, you guys. Woo! We did good work. We did hard work. Super proud of you. If you have any questions about this, post them in the Facebook group. Okay, you guys, I'm drowning here in questions. So my admins there are the first line of defense. They'll help you. And then if they can't help you, then I'll come in and I'll help. And otherwise, if it's looking good, just keep moving on. You're doing great. This is challenge work. Proud of you.